All right, in this video, we're going to be finding volumes using this disk method. So last time we had, in the last assignment, we had like a shape and there was a shaded region, and then out of that shaded region, there would come several cross sections, and we would add up the areas of those 2D figures, and it gave us a volume. All right, what we're doing on this one is we'll be given some graph or some section, and then what's going to happen is this thing is going to rotate around either the x-axis or the y-axis, and when that thing rotates around, it is going to form a shape. So if I think about it, let's take this little rectangle here, and the R is going to be the radius. The W is going to be the width of that rectangle. And that width, now in a second, we're going to try to make this width infinitely small. So it's going to be basically 0 was the idea of getting really close to 0. But if I had that width, and it's like an actual rectangle, if I spun that thing around the x-axis here, that would form a 3D shape. It would form this disc over here. It looks like a little hockey puck. That's what I see. All right, so a two-dimensional figure, when it's rotated around the x-axis or the y-axis, it becomes a three-dimensional figure. So recall the formula for a cylinder. It's the volume is equal to pi times the radius squared times the height. So it's the big B times H is the area of or the volume of a prism, right? So the big B is the base. In this case, the base is going to be a circle, so it's pi r squared times the height. So the disk is basically a very, 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 very short cylinder where the height is it's like the W value, which is basically going to be 0. So to find the volume of these solids, so a solid of revolution is what this is called, the fancy way. With the disk method, we have these two formulas. They're basically the same. So if I'm rotating this thing around the horizontal axis, I would have all of these radiuses, or I could even say it's a little rectangle with infinitely small width. And if I rotate them around the x-axis, I form a three-dimensional shape. In this one, I mean, you can almost picture, oh, this is kind of hard to draw. It would be kind of like that shape, right? Where that's the x-axis and that's rotated around. Okay, each cross section, this time, if I cut it and opened it up, it would be a circle every single time. So the volume is going to be adding up all of those circles. So the volume is going to be from A to B. So if I'm rotating around the x-axis, I'm finding all where those circles start to where they would end. Those cross sections. So it would be from A to B, and it would be the area of that circle, right? So it'd be pi. I don't know what I draw that pi for. It would be pi times the radiuses squared times the height. But the height is basically the dx. It's that change in x. So the pi is going to go out in front. So I just have the volume from A to B, pi out in front, the radius squared dx. So all I really need to do is find the radius. And the radius in this case is going to be, in terms of x, it's going to be whatever this function is, right? So for different x values, the y value would be the radius value. Okay, same thing happens, same idea if I rotate around the y-axis. This time, so if I rotate around the y-axis, it would be a little bit different shape looking. This one would, well, be kind of the same thing. It'd be like over here. I just picture like a little dome. I don't know if y'all picture it. But when you take those cross sections, I would go from C to D, and it would be the radius, but this time it's a dy. So this time the radius will have a y. It'd be like x equals 2y minus 3. So it'd be in terms of y because you're doing dy. All right, so we'll do some examples and we'll try to get a visual what this looks like. When we do this in class, we're going to have a whole bunch of candy that day. It's kind of a fun one. And that just to help you visualize what shape these are forming. All right, so it says, using the disk method, find the volume of the solid formed by revolving this region that we have. Take that whole region. Oh, I'm supposed to be coloring in. So I'm going to color. This region, and I'm going to be rotating it around the x-axis from 0 to pi. So use the graph and the shade of the region to represent and see what's going on. Okay, so if I rotate this thing around, it's not going to be a perfect like circle or sphere. It's not going to be a ball. It's going to be like a little bit of an oblong ball. If you can picture that, it kind of looks like a jelly bean. Here's my examples. Okay. All right, so since I'm rotating around the x-axis, it's going to be in terms of x. And the volume is going to be pi from 0 to pi again. So it's from 0 to pi. So here's my cross sections going this way. So they go from 0 to pi. And it's the radius squared. The radius in this case, the radius of each circle would be function value. So it would be the square root of sine x squared. So the volume is pi times the radius squared, and then this is your height right there, but it's just dx. All right, so now we solve this down. This would be pi. What we're going to do this step right here is we're going to remove that squared. The squared takes away the square root. The antiderivative of sine is negative cosine. And I evaluate that from 0 to pi. So this volume is going to be pi, okay, negative cosine of pi. Okay, cosine is the x number of pi, so -1, and negative 1 is 1. Cosine of 0 is positive 1, so I'm subtracting a, oh, crud. All right, so it's negative cosine, right? Okay, so I might have done that right, but okay, negative of whatever cosine of pi of, but cosine of pi is -1. Okay, I think I did that right. Minus whatever negative of cosine of 0 is. Cosine of 0 is +1. So this is what? Pi times 1 plus 1. Okay, I think I would have got that right. So 2 pi is the volume of that shape. So with that little area, that little form, that little shape, if I rotate around the x-axis, and the volume would be 2 pi. And I can hopefully visualize that jelly bean. If you picture a jelly bean and cutting it, and you open up the jelly bean, you should be able to see that they're both circles. The cross sections are always circles. All right, think about it. The concept of the disk method can be linked to the previous technique in finding the volume using cross sections. What shape is the cross section always? Oh, I was going to build circle. Can't spell circle. It's not an S. It's a circle, always. All right, let's do some more examples. Okay, rotate the region enclosed by, oh, there's no picture this time. Sad. Enclosed by y equals x squared, y equals 0, and x equals 2 about the x-axis. Okay, let's draw a picture. Draw your axis. Okay, I've got y equals x squared. Looks like that. Y equals 0. That's the horizontal x-axis. And x equals 2. So this is x is equal to 2. So I'm trying to find this. Here's my shape. I'm going to rotate that thing around the x-axis. So if I can picture that, spin that thing around the x-axis, spin it really fast, and this like little shape that we have here is going to like sweep around a whole full time, and it's going to form a 3D shape. Can you visualize what that 3D shape looks like? Can you visualize what candy that would look like? And I'm just going to tell you, I think it looks like a Hershey Kiss. Maybe I should have a picture of a Hershey Kiss so you can confirm that, but you should know what a Hershey Kiss is. All right, so the volume is going to be equal to pi from 0 to 2. The radius is just function value. It's in terms of x, so this is x squared squared. It's the radius squared dx. So the volume would be equal to pi from 0 to 2, because this is 0 to 2. Those are all my cross sections. Of x to the fourth dx. The volume is equal to pi times, this would be x to the fifth times 1/5. Evaluated from 0 to 2. If I plug in 0, it's just going to be gone. So volume is equal to, okay, 2 to the fifth. Oh, I don't know. 2 is 4, 8, 16, 32. So 32 over 5 pi would be our volume. All right, let's do another one. Okay, consider the region enclosed by the line y equals 1/2 x minus 1, y equals 0, y equals 2, and x equals 0. Then find the volume of the solid that has been formed if I rotate that thing around the y-axis this time. So this time it's around the y-axis, which will be a little bit different. Let's sketch our picture. Y is equal to 1/2 x minus 1. So cross starts at -1, goes up 1, over 2, up 1, over 2, up 1, over 2. So this would be what, 2, 4. This would be over here at 6. This is 1, and this would be 2. Might not need all those points, but we'll see. All right, so so there's that line. And then also between y equals 0, y equals 2, and x equals 0. All right, so the shape here looks like that. And I'm going to rotate it around the y-axis. So flip the thing around. What candy can that kind of look like? It kind of looks like a Reese's peanut butter cup. And hopefully if you see it in person and we have the Reese's, you're going to see it. And all the cross sections are going to be going this way this time. And if I cut it, I should be able to see a whole bunch of circles. And all the circles are different sizes. So our volume will be equal to pi. From this time from 0 to 2, I'm going along the y-axis. I'm rotating around the y-axis, so find your numbers from your limits of integration from the y-axis, dy. But this time the radius, each time it's going to be green. It's whatever this value is. But it has to be in terms of y because we're integrating with respect to y. So I'm going to take my function and I'm going to solve it for x. Multiply by 2, so 2y plus 2 is equal to x. So that would be my radius squared. So that's the hard part to kind of come up with. It's also kind of fun because you can visualize what it looks like in terms of a candy. So now to integrate this is the same old. We're getting hopefully pretty good at integration. This one, I could do u substitution. On this one, I think I'm going to multiply this out. I'm going to say 2y plus 2 times itself. That gives me 4y squared plus 4y plus 4y, so 8y plus 4, and then just integrate that. But you could do a u sub with this also. That would be fine. Gives you the same thing. Oh, come back. Oh, what is this? I've never seen a crayon. Let's see if you write in crayon. See if anyone even bothers. You can watch this, then. Oh, that's awful. Okay, why is that so bad? Why can't there be like a little small crayon? All right, never mind. Go back to the little pen. All right, so the volume is equal to pi times, what would that be? 3, multiplied by the reciprocal, 4/3 plus y squared times the reciprocal, 1/2 times 8, plus 4y. You vary from 0 to 2. If I plug in 0, it's all gone. Like those just don't matter. So this is really just the volume is equal to pi times 4/3 times 8. And that's 2 cubed plus 4 times 4 plus 4 times 2. Okay, this is, I think I wrote the answer down already. What is this? Oh, I just left like this. No, I left like this. But that would be a safe stop. This would be 32 over 3 plus 16 plus 8, and that's the answer. That's the volume. You could combine if you want to. All right, let's do another one. All right, number 4. Consider the region in the first quadrant enclosed by that function. Find the volume of the solid formed by revolving this region around the x-axis. Okay, I want you to pause on this one, and I want you to see if you can do this one without watching. Like, with what you know, try your best to do this one. Okay, you've paused it, you've unpaused it. Okay, let's check, see if you got it right. Consider this region. Okay, so it's in the first quadrant, and it's f of x equals 4 minus x squared. All right, so that means it crosses the y-axis at 4 and it opens downward like that. It's only the first quadrant. So when this would be 0, when y is 0, 4 minus x squared is equal to 4. So this would be 2. The x number is 2. I'm revolving it around the x-axis, so I'm going to get my limits of integration from the x-axis. So it'd be from 0 to 2. My cross sections are going to be looking like this, but it's going to be full shapes, right? It's going to go all the way down here, and if I picture that three-dimensional, that is going to look like a vanilla wafer, or just any kind of cookie. Maybe a Chips Ahoy cookie, or an actually really good cookie. Chips Ahoy's kind of overrated, kind of hard, like the chewy ones though. All right, so from 0 to 2, okay, what are we doing again? What is the, so it would be dx, I'm rotating around the x-axis, so dx. So it would be, the radius is 4 minus x squared, and then, I guess just, oh, forgot the pi. All right, so this would be volume is equal to pi from 0 to 2. I could do a u sub. No, I couldn't. I would have to multiply this one out, right? This is going to be gross. If I did u sub here, I would have dx would be 2x, and there's no other x term, so yeah, u substitution would not work here. So I'm going to go off to the side. I'm going to expand this out. You might be able to do this in your head. I'm not that smart. Minus 8, you probably know that by now. X to the 4th. So 16 minus 8x squared plus x to the 4th dx. Integrate each term with respect to x. I've got volume is equal to pi. 16x minus 8 thirds x cubed plus 1/5 x to the 5th. Evaluate from 0 to 2. Plugging in 0 doesn't, it's just all 0. So volume is equal to pi times 32 minus 8 over 3 times 8 plus 1 over 5. 2 to the 5th. I think we just did that a second ago. I forgot already. 2 times 2 is 4. Then 8 is 3. 16, so 32. All right, and there would be a safe stop. All right, so let's do number 5 is the exact same shape, but this time, let me draw a little better. This is 2, this is 4. This time we're rotating around the y-axis. So the volume would be pi from 0 to 4 dy. If I'm trying to find my radius, this time it'll be in terms of y. So the radius will be going this way. So it's whatever that function was. This was y equals 4 minus x squared. Then we'll solve it for x. I'll solve for x. So y minus 4 is equal to negative x squared. So 4 minus y is equal to x squared. So x is equal to the square root of 4 minus y. And we'll use the positive root because it's a positive distance. So it'd be that thing, square root of that squared. And the reason I write this every single time is because this might be a multiple choice, and it just wants to know what the integral would be to set it up. It might not actually have you solve it. So it might look like that, but next step I would reduce, find the antiderivative. So it'd be 4y minus 1/2 y squared. So squared. Evaluate it from 0 to 4. Plugging in the 4. I would plug in 0, but if I plug in 0, it's just going to be 0 minus 0. So I don't forget to do that though. Just this would be 16 minus 1/2 of 16. So this one would be 8 pi. So a little bit different shape. If you can visualize this one, this is the worst candy of all time. This would look like a dot or a gumdrop. Hopefully I can find some dots this year. Last year I couldn't find any. I didn't really look that hard, but the dots, those are disgusting. Probably no one wanted it anyway. Or those little gumdrops, they put on the gingerbread houses in Christmas time. All right, I think we have like 2. Let's just do one more. Do 2 more. Number 7 is actually one we're going to do the next class. So that's going to be an in-person one. I don't want to put it on the notes. It'll be with the washer method when we learn how to do that though. Okay. Consider the region enclosed by y equals x squared, y equals 0, x equals 3. Find the volume of solid formed when you rotate around a line x equals 3. All right, so it's not the x-axis or the y-axis.